Hello everyone, in this video we will talk about a new topic, Newton-Raphson method in n dimensions, that is the Newton-Raphson method for a system of equations. This part of material is in chapter 12, it's page 293 on the textbook. So the problem is still a root finding problem, but for all the previous topics, we are using scalar valued function, but this time we will use a vector valued function. And the problem is that given n functions, each of n variables, so the function is f1, f2 until fn, and each function has n variables, x1, x2 until xn. So the problem is that we want to find vector r called a root such that fr is equal to 0. The assumptions, so we assume that each of the functions fi, I from 1 to n, is continuous and it has continuous partial derivatives. Remember that for scalar valued function, we assume that the function is continuous, also it has continuous derivative. So for a vector valued function, we assume each function is continuous and also each function has continuous partial derivatives. The initial requirements, so we always start from a single initial guess. So we have a initial approximation vector 0 of the root, and we have calculated the Jacobian. So the Jacobian is shown in this matrix. In essence, the Jacobian is analogous to the derivative of the multivariate function. So the iteration process, remember that the formula for a scalar valued function, so scalar valued function, the formula for the iteration process of Newton-Raphson is xi plus 1 equal to xi minus fxi over the derivative of fx at xi. And this is the scalar valued function. So for vector valued function, the formula for the iteration process is the analogous to this formula. So they look very similar. So the vector xi plus 1 is equal to the vector xi minus the inverse of Jacobian evaluated at xi times, so this is the inverse, times the function value, the vector f at the vector evaluated at the vector xi. All right, so this will be a n times 1 vector, and this is a n times 1 vector, and this Jacobian matrix is a n by n matrix, and this function value is also a n by 1 vector. All right, so this is the formula for the iteration process. It's very similar to the formula for Newton-Raphson method for scalar valued function. We just need to change the derivative into a Jacobian matrix, and also the approximation of the root changed from a single variable to a vector which has n variables. So in the next slides, in the next video, we will talk about the halting condition of Newton-Raphson method in n dimensions.